Hi everyone, thanks for joining our talk about the vulnerability research we've been doing on space systems. So just quick introduction of the team. So my name is Milenko. I'm currently leading the team at Vision Space. On stage today with me is Andy.
Yeah, my name is Andrzej. I've been working for Vision Space since a couple of years now, and prior to that I used to work at the European Space Operations Center for a little bit over a decade.
Also in the room, Ricardo on the first row. And unfortunately, Ayman had to already go. So why are we talking about space systems, and why do we think it has an impact on the wider society and not just on us in the space industry? And what we see is that there is a huge number of satellites being launched currently, and the attack surface is exploding. It's huge. So there is not just a couple of satellites as it used to be like in the 80s when only government was building satellites, but commercial providers like SpaceX, OneWeb are pumping out more and more satellites into orbit. And next to that, what we see is that also the defense industry is catching up again. So after the Cold War, there was a bit of a cool down in the launches for like telecommunications, for example, for the military. But nowadays, this is always increasing. And in addition to that, most of the constellations that are currently being launched have some dual use potential. Like we see that with Starlink used in the front lines in Ukraine, for example. And there's like military contracts also in the US, but also with OneWeb internationally. There's a huge incentive for APTs and governments actually to look into attacking these systems. And we think that they are not prepared for that. Just for everyone who's not from the space industry, just to give you a little bit of background how a space system works. So we have very basically a satellite or multiple satellites, and we call this the space segment. Then we have the ground segment, which is on the ground, and all the infrastructure here on the terrestrial side, which is supporting the space mission. So for example, a mission control center, which has operators in it, the fibers which are going to the ground stations or leased lines that you might have, the ground station infrastructure itself, science centers, etc. There's a huge number of IT assets and OT technology which are supporting a mission. And then we have the user segment, and this is where we saw a lot of the previous research being done. So user equipment that you can actually hold in your hand, that you can buy, like a Starlink dish that you can tear apart and look what it's inside. And where we saw a bit the gap was actually on the other two segments. So a lot of people in the past decades were doing research on how to intercept communication, how to play with the modems, but not so much on how to actually control a spacecraft, or what you can do if you can actually send data directly to the spacecraft, if you can maybe bypass authentication, if you can mess with the memory, how the safety systems that were built in affect security. So an example science mission, how this usually is structured. So you have one or multiple spacecrafts doing their thing. You have an RF link to a network of ground stations, usually not just one. And then you have a mission control center that can be just a room, that can also be a building or multiple sites with redundancy. And then you have something like a science data center, sometimes multiple, and these are post-processing the data that is coming from the spacecraft to serve it to the end users, so scientists in this example. Of course, a telecommunications mission looks different, so this is just an example. And then you have an operator or multiple operators, usually a team, who are controlling the spacecraft. So they are taking care of the health of the spacecraft. Is it in a good state? Are the batteries okay? Do we need to do something about the orbit? Do we need to plan some maneuvers? Is there some space debris incoming or whatever? And especially since COVID, there's not longer this perimeter-based defense. So now you also have operators using a VPN to connect, to control the spacecraft from home, for example, or just remotely. So teams are working remotely. Things are moving to the cloud. You can now book on AWS, but also on Azure. You can actually book ground station passes directly and get it into the data center. So there's a lot of shift in how the infrastructure is working. But the software that is used inside there hasn't changed much. So if you have a big mission, the software that is used to control the actual spacecraft, so the human-machine interface that the operator uses to control the spacecraft, is likely built on decades of experience and code base. So we looked into open source versions of this. So there's, for example, YAMCS, which is used by dozens of missions, especially smaller missions, but also being planned to use on lunar rovers and the European robotic arm on the ISS. We have NASA's OpenMCT, which is used for the Mars rovers, for example. And we have OpenC3 Cosmos, which is also gaining popularity. And then you have onboard software. So some spacecraft have a very tailored onboard software. That's not something we looked into. We looked into software that is reused across missions, so that dozens of missions are actually affected if there is something in that. And the best example for that is NASA's core flight system. So this is used, I think this is built on above 20 years of legacy, actually, this system, and used in dozens of missions. There's also like payloads on the James Webb Space Telescope, which are running this software. Then we looked into F-Prime. So this is also from NASA, and this was developed originally for the Mars helicopter Ingenuity, and AIT Core, which is used to run experiments on the ISS. So traditionally, what disabling a satellite would mean is actually launching a rocket at it. So in the 80s approach, I would say, is actually you get your fighter jet up and shoot a rocket at it. But what we found is that actually you might have a much easier time if you exploit the vulnerabilities in the ground segment or in the spacecraft system. So now comes the fun part. I hand over to Andy for some live demos.
Okay, so what you're gonna see now are a couple of demos showing different type of vulnerabilities, different attack vectors, and also different ways of exploiting them. We're gonna start with mission control system. For this particular case, or in this particular case, we're gonna use OpenC3 mission control system. The system is vulnerable to a number of different issues. It has a number of different issues. Some of them are easier or more difficult to exploit, and one of them is an XSS, which you'll see in a second should give us an RCE to the system that is actually controlling the spacecraft. So in order to pull this off, we are gonna generate a URL, which we'll then try to fish a user with for a given mission, and then we'll take over control of the system. So I'm gonna Okay, so I'm gonna start the OpenC3 system. It is one of the more established mission control systems. Space industry is going to take a second to load. It goes with a bunch of typical functionalities you might find on any other mission control system. Some of, like, for instance, telemetry processing and displaying. You also have commanding capabilities where you can actually send telecommands to spacecraft. And OpenC3 also has a script runner where you can customize your functionality with Ruby and I think Python it was. And as I mentioned before, this system is vulnerable, among other issues, also to an XSS. To exploit this vulnerability, there are a number of calls that payload we generate has to make. One of them is first is to steal the session tokens in order to which we then use to deploy the malicious script on the system, and then eventually we trigger that script. So to make it easier for us, we create a Python script to generate the URL, which we then use to fish our victim. And then we are going to start the listener. So let's say I'm a spacecraft controller and I fall for the phishing campaign. I clicked on a link. So from my perspective, nothing really happens. I still have access to my mission control system and all its functionality. But the adversaries have access to to the whole system that is de facto controlling the spacecraft. So that was one demo. I'm gonna quickly stop it so that I have resources to conduct the next one. Okay, so and the next demo is a little bit different. We are not targeting the ground segments. We are the ground segment and the mission control system. We are targeting the spacecraft itself. So imagine that you are a nation state and you have access to a ground segment in your country and mission control. So let's also assume that you are in the visibility of the spacecraft. So we actually can send some data to spacecraft. And then the last assumption is that this spacecraft is running an older version of NASA core flight system, which is vulnerable. Again, quite a few vulnerabilities, but one of the particular weakness we're gonna use is on the memory management module in order to get an RCE at the spacecraft directly, at the spacecraft platform. So again, I'll start the core flight system simulation and a listener. This one is a little bit more complex in the exploitation. As mentioned before, the memory management module of the core flight system is weak when it comes to, so in principle, the module should let you write and read memory in the memory, right? It doesn't impose any restrictions on which parts of the memory address you can actually write, which means that you can read or write memory not only to the memory of that module, but the entire process of core flight system. And because CFS is running on a Linux type operating system, well, you can imagine there's a lot we can actually do with this type of vulnerability. What we are gonna do in this case, we're gonna tap into global offset table, grab a couple of addresses of functions we want to execute, or the function which is executed next, and then another one which we want to replace it with, and we just let it run, and that will actually execute the function which we want to execute instead of the one that is in the software. So I will run the simulation now. So the simulation is running. I will run the exploit now, and then I will walk you through. I will walk you through the steps. So in our particular case, we are interested, because of the research we did, we know that when we send the telecommand, one of the next functions that is called is the memchr. So we are replacing that function with the system, and then we're finding the addresses, then we place those addresses or swap those addresses on the global offset table so that the next instruction that is going to be executed instead of memchr, it's going to be the system one. Now, what you see now is the telemetry coming down from the spacecraft. So there is a constant communication between the ground segment and the spacecraft because we have to leak those memory addresses. And okay, it has completed. So we can see that we have leaked the memchr from the global offset table from the spacecraft platform, and then we have overwritten that function with the address of the system function at the spacecraft by sending telecommand, which we then use to pass our payload. And just for the sake of demonstration, it was executed, and we got the reverse shell back from a system on which the CFS is running, which in our case is a spacecraft. So that concludes the demo.
Okay, demo bots were good to us today. So this is the list of software that we actually looked into. So we just showed 2 of them, and as you might see, just some of the vulnerabilities that we actually discovered over the past years. So we started 2023, I think, with the first disclosures, and yeah, the list is going on. And this is not because this is bad software. This software was running operationally for years without major problems. It's being maintained. We reported these things. They were fixed within weeks. Usually the maintainer teams were very nice and responsive. But no one was actually telling them to write secure software, it seems. So this seems to be more of an issue. So one of the concerning things is that not that we just found some XSS, which is like not the worst, but that in most of the systems we either found a high or critical vulnerability, which could lead like to code execution or, for example, arbitrary file deletion in YAMCS, where you could just wipe the disk. So sure enough, we published some things and got some attention. So some others jumped in. So it's always a bit painful when you publish something and then a couple of months later you see that someone else found more. But yeah, so this was actually quite a nice follow-up research that was done, I think by a French researcher. And they found actually ways to bypass in one of the plugins for NASA's core flight system, which is supposed to provide encryption and authentication, ways to bypass it. So we already found some ways to mess with it, but he actually found some ways to bypass it. And even later, more people started looking into it, and there was much more, which we didn't even check. Like, we were checking the code, we were not running memory checks, but yeah, someone I think was firing up Valgrant and was finding much more things which were also pretty severe in that software. And so what we think is like, there's a bit of, in the space industry, a bit lack of awareness on the developer side, but also on the management side, what is important there. And it's difficult to implement this late. So some of the functions, for example, like memory access or something, that needs to be something that needs to be discussed at the very beginning if you want to have that level of access or not. And if you have an existing mission which has this level of access, it's very hard to secure it. And if this is something that is relevant to your security or like has a dual use characteristic, then maybe some hard decisions should be taken on how to use that mission. So we think that while space is hard, space security doesn't need to be hard. Just a final touch. So we're currently running a space CTF. So if you liked what you saw here, you might also enjoy our aerospace village Starpone CTF. Thank you.